Bit forms the first three letters of the word Bitcoin. But what is a bit? Before we can answer that question, we need to ask ourselves what data is. Let's define data as just stuff on your computer. Word docs, images, text files, audio clips, and much, much more. But the real question is, how does your computer represent that data internally? You don't just crumple up images and stuff them inside your computer case, do you? Here, let's say we have a lighthouse. In order to communicate with incoming ships, the lighthouse can flash a special light that can either be green or red. If the light is green, that means it's safe for the incoming ship to pass. If it's red, that means it's not safe to pass. This is all fine, but what if the lighthouse wanted to give the incoming ships more information? For example, what if the lighthouse wanted to give number codes ranging from 0 to 7? 0 would mean incoming ships need to stop, and every number above that would represent how many seconds before the incoming ship would be allowed to pass. Thus, a 1 would mean the ship could pass after 1 second, a 2 would mean the ship could pass after 2 seconds, and so on. How could we represent this? Should we introduce a new color? That's not possible because it just so happens that these special lights only come in two colors, red and green. What if we added a new light? Each combination of lights would represent one of the number codes. As we can see, 3 lights could be used to form 8 combinations, and each combination could be assigned to some numerical meaning. These lights don't have to just be related to numbers. We can also use the lights to mean things related to text. In fact, on the other side of the lighthouse, there are ships that only respond to text type information and not number type information. Thus, the lighthouse might flash 3 red lights, which would be interpreted differently by ships coming from opposite directions. The lighthouse here is like a computer. However, instead of green lights and red lights, computers represent everything with electrical switches that can be on or off. Oftentimes, we describe these two states as 1 and 0. In turn, we refer to these two numbers as binary digits, or bits for short. Much like how the lighthouse put together a series of green-red lights to describe information, computers represent documents, pictures, and more with just lots of 1s and 0. In computer jargon, a sequence of symbols is oftentimes called a string. So data is represented on your computer as a string of bits. But one question remains. How does the computer know what type of data it's working with? Does the string of bits it's currently looking at refer to a number or a character? Looking back at the lighthouse example, the lighthouse was receiving traffic from 2 different directions. Thus, the direction the lights were pointing told the lighthouse what type of data it was working with. Similarly, context is what tells a computer what type of data it is working with. If bits are sent to a calculator program on your computer, the bits might be interpreted as numbers. But if sent to an image viewing program, the bits might be interpreted as an image. In short, bits are just 1s and 0s that represent a whole bunch of cool stuff on your computer. See you next time.